Hi, my name is Muhammad Hadif. My group member consists of Alim, Arif, Fahim, and Farid. Today, we will be presenting about our computer architecture and organization project.
For the introduction part, the purpose of our program is to create a simple calculator program that can be used to add, subtract, multiply, and division by using assembly language. For our programming language, we use Qt-SPIM. The key functionalities of our program is it can add two numbers, subtract two numbers, multiply two numbers, and division of two numbers.
This is the coding that we create together in assembly language.
This is the output sample of our program. First of all, it will welcome the user by displaying the prompt or the message welcome to the calculator program. And after that, it asks for the first input or the first number, which we enter 23. And after that, it asks for the second number, which we enter 34. After we enter the two numbers, we have to choose the operation between adding, subtracting, multiplying, or division. So, for the additional features, we're implementing a user-friendly approach to our user. After displaying the result, the program asks the user if they want to continue or exit the program.
Implementation detail. .text contains the executable code beginning at the main label, implements the program logic for input handling, calculation, error checking, and result display. It includes logical sections for operations, error handling, and continuation prompts. Second, key algorithm and data flow. Input handling. The program asks for the first and second numbers and asks for prompts for an operator. Operation selection. Based on the operator entered, adds the number, subtracts the number, multiplies the numbers, divides the numbers. Error handling. If the user enters but the second number is 0, it displays an error and restarts. If the operator is invalid, it shows the message and restarts. Continuation logic. After displaying the result, the program asks the user to whether they want to continue Y or exit N. Register usage. Key register. +0 stores the first number, +1 stores the second number, +2 stores the operator, +3 stores the result of the calculation. System call registers. V0 used to make system calls input and output. 00 passes argument for system calls, example given text to print. Temporary data flow. Inputs are stored in +0, +1, and +2. The result of the calculation is stored in +3 for display. The program ensures user interaction and error handling using loops and control structures. As you can see on the diagram, the purpose is to enable multiple calculations without restarting. How it functions is by after a calculation, the user can input Y to restart the loop and input N to exit the program. The program controls flow using conditional checks and branching. First, operation selection. Branches to the correct operation, plus, minus, multiple, and division, or invalid operator for invalid inputs. Secondly, division error check. Redirects to division error if the divisor is 0. Third, invalid operator. Handles unsupported operators by jumping to invalid operator. Lastly, continuation check. Restarts, calculate start on Y or exit program on N. This ensures smooth and error-free operation. The program uses conditional checks and branching to manage control flow effectively. Initialization. Displays a welcome message and starts the main loop, calculate stat to process inputs. Operation selection. Branches to the chosen arithmetic operation or handles invalid operators. Error handling. Redirects to handle errors like invalid inputs or division by 0. Continuation or exit. After each calculation, it asks the user to continue or exit program. This structure ensures smooth transitions and reliable program execution. The program uses conditional checks and branching to manage flow. It starts by displaying a welcome message and entering a loop to process inputs. Based on the operator, it performs the operation or handles errors like invalid inputs or division by 0. After each calculation, it prompts the user to continue or exit, ensuring smooth transition and error handling. One of the error handling mechanisms that can be described is division by 0 prevention. Before performing division, the program checks if the divisor is 0, as can be seen on the coding below. If the divisor is 0, it redirects to division error, which displays as shown. Another error handling mechanism is invalid operator handling, where if the user enters an unsupported operator, the program redirects to an error message and restart the loop. There are many importance of error handling. Some of it are program stability, user feedback, and usability. User interface design. Initial greeting. When users launch the program, they are welcomed with a friendly message. For example, welcome to the calculator program. This sets a positive and user-focused tone from the very start. Second, prompt sequentially for the first number, second number, and the operation. The program guides users step by step to input the following. First number, enter the first number. Second number, enter the second number. Operator, choose an operation. The prompts are direct and designed to reduce ambiguity. Thirdly, display the result of the calculation. Once the input are provided, the program performs the calculation and presents the results clearly. Fourth, error handling messages. If there's an issue, such as division by 0 or invalid operators. For example, the feedback is invalid operator. Please enter plus, minus, or slash. These messages are informative, guiding users to make the correct inputs. And lastly, ask if the user wants to perform another calculation, allowing continuous interaction or exiting with a polite message. Creative enhancement to the user experience. Error handling. Clear descriptive error messages for invalid input or division by 0. Interactive loop. Users can calculate repeatedly or exit without restarting the program. Third, simple and clean flow. Input prompts and outputs are straightforward, ensuring an intuitive experience. And lastly, formatted messages. Results and prompts are well structured for clarity in the command line display. Challenges and solution. So, there are two things for the challenges and solutions, which is, first is major challenges during development, debugging control flow, especially branching and looping for repeated calculations. Second, handling errors like division by 0 and invalid operators without crashing. Thirdly, managing seamless input and output for integers and characters. B. Solutions. Used Mars Simulator to trace execution and debug branching issues step by step. Implemented clear error handling labels for invalid inputs and division by 0 checks. And lastly, tested cycles thoroughly for correct input, output, and ensured proper prompts and formatting. And lastly, conclusion and reflection. So this project was a great way to learn the basics of assembly language. By creating a calculator, I understood now how arithmetic operations like addition, subtraction, multiplication, and division work at a low level. So what do I learn in key learnings? Direct control. Writing instructions directly for the CPU to give us a better understanding of how computers work. Secondly, logic and structure. Breaking the program into steps input, operation, and output was crucial for creating a working solution. And lastly, error handling. Managing a division by 0 taught us the importance of addressing special cases. Reflection on assembly language concepts. I gain a better understanding of how basic operations are handled at a low level in assembly language. We learn how to manage control flow using conditions and branching. And we improve error handling skills, especially for division by 0. And we develop problem-solving skills and attention to detail in low-level programming. Lastly, we strengthen our foundation in assembly language concepts and their real-world applications. Overall, this project helped me improve my understanding of assembly language and how low-level programming works. It also made me appreciate how high-level language simplify this task. Okay, that is all from us. Goodbye.